In this video, we will learn how to solve some problems in statistics and probability. And the first is the fundamental principle of counting. So the problem is, how many 5-digit numbers can be formed using the digits 0 to 9 if A. Repetitions of digit is not allowed. So here is 5 digits, 2, 3, 4, 5. So repetition of digits is allowed. So this one will be 9 because 1 to 9 is allowed, because if we use 0 in this, in the first digit, it will become 4 digit only. So next is 10 digits, 10, 10, and 10, because repetition of digits is allowed, so we use all 10, so it is equals to 90,000. So the next condition is repetition of digits is not allowed. So 5 digits again. So repetition of digits is not allowed. So we still use 9 here, because since we can't use 0 in the first digit, so we use 9. And next is, because we used one digit on the first digit, so one number in the first digit, it will become 9, because here is 1 to 9, and here is, if we take 1 here, so it will be 9, and this one will still 1 to 9 or 2 to 9, because we take 1. So next is 8, because 2 are taken already in the first 2 digits, so 7 and 6, and it is equals to 27,216. So the next condition, letter C, is the numbers are even and repetition of digits is allowed. So 5 digits again. So it says that the numbers are even, so it should be even at the last. So we get 2, 4, 6, 8, and 0. 0, 2, 4, 6, 8 as the last digit to make it even, an even number. So it should be 5, and the repetition of digits is allowed. So this one still 1 to 9, so it is 9. So repetition is allowed, so it will be 10, 10, and 10. So the answer will be 45,000. And next is the odd number is odd and repetition of digit is not allowed. So 1, 2, 3, 4, 5. In this condition, it should be odd number. So the last digits, so in the last digit, we can only use 1, 3, 5, 7, and 9. So it will count as 5 possible numbers to be in the last digit. So the repetition of digit is not allowed. So we have to use 8, because we already used the first number in the last digit. So, and also the 0, we couldn't use it in the first one, so it will be 8. And next is 8 also, because 2 are already used. So next is 7 and 6, because repetition is not allowed again. So the answer in this multiplication, if we multiplied all of them, it will be 13,440. So this is the answer for this condition of 5 digit using 0 to 9. So for the last condition for this problem, the condition E, the number is greater than 50,000, but it is odd number. So 5 digits. So for the last digit, he said odd number. So we can only use 1, 3, 5, 7, and 9. So the last digit should be 5. And for the first digit, so it should be the number with 5 digits is should be greater than 50,000. So the numbers greater than 50,000 for the first digit is 5, 6, 7, 8, and 9. So it's also 5. Then next is we already used 2 digits for this one, so it will be 8, 7, and 6. So we use 5 here as 5, 6, 7, 8, and 9. So since we use 5 here, so it will be 50,000, and it is odd number. 1 is used here and no 0 being used in the last digit. So all digits we have used is greater than 50,000. So 5 times 8 times 7 times 6 times 5 is equals to 8,400. So now let's talk about the permutations. So the first problem is how many different 3 letters and 3-digit password can be created for a software access if no letters and no digit can be used more than once. Now, the password is contained about 3 letters and 3 digits. So these are the letters, and these are the digits. For the letters, we can use the English alphabet. So A to Z is to are 26 letters, and the digits are 0 to 9, so 10 numbers. Then the condition is no letter and no digits can be used more than once. So the first is 26, and it says that letters and digits can be used for more than once. So 26, the first letter is already used in the first line. So this will be 25, and the third is 24 because 2 letters are already used. So for the digits, so 10 digits are possible. Now it will be 10 because nothing already used. So and next is 9 because 1 is already used in the first digit, and 8. So to multiply 26 times 25 times 24 times 10 times 9 times 8, it is equals to 11,232,000. 11,232,000 possible outcomes. Now for the second problem concerning permutations, it, it is circular permutation. So the problem is how many ways can 4 boys and 4 girls be seated at a round table? So the first condition is if no restrictions are imposed. So the round table contains 8 persons, 4 boys, and 4 girls. So no restrictions or conditions are imposed. Now there are 8 people. So the formula for the permutation, circular permutation, is n minus 1 factorial. So the n is the number of people or the number of characters. N is equals to 8. So p is equals to 8 minus 1 factorial. So it is equals to 7 factorial. So the permutation is equals to 50,000, 5,040. So there are 5,040 possible outcomes if there are no restrictions imposed. For the next conditions in circular permutation of the problem, how many ways can 4 boys and 4 girls be seated at a round table if the girls and boys are to occupy the alternate seats? So the girls and boys occupies alternate seats. Girl, boy, and girl, boy, and girl, boy. So the formula to use this is there are 4 girls. So permutation is equals to 4 minus 1 factorial and multiply it to the boys, or 4 factorial. Only one circular permutations is used because if two circular permutation are used, the answer is false. So let's use this formula. 4 minus 1 is 3 factorial times 4 factorial. 3 factorial is equal to 6 times 4 factorial is equal to 24. So the permutation for this condition is 6 times 24. It is equals to 144. There are 144 possible outcomes if the girls and boys are to occupy alternate seats. And for the last condition in this circular permutation problem, if two particular girls must sit together. Now, there are 8 people around the round table. So, there are 4 girls and 4 boys. So, 2 girls must sit together. Now, there are only 7, 7, 1, 2, 3, 4, because they count as 1 because they should be together. 1, 2, 3, 4, 5, 6, 7. So permutation is equals to 7. So because it is circular permutation, we should minus 1 quantity factorial. And for another arrangement, these two can be arranged into 2 factorial. So 7 minus 1 is equal to 6 factorial multiplied by 2 factorial. Now 6 factorial is equal to 720 and 2 factorial is equals to 2. It is equals to 720 times 2 is equals to 1,440. So 1,440 possible outcomes if two particular girls must sit together. Now for the third problem, concerning repetitions, particularly now with repetitions. Number 3 is how many different ways can the letters in the word committee can be arranged. So the word committee has 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we write 9 factorial because there are 9 letters, and using the permutation with repetition, we divide it to the letters that has the same characters. Examples is the M. There are 2 M's, so divide it into 2 factorial. And there are 2 T, so 2 factorial, and 2 E's, so 2 factorial. So 9 factorial is equals to 362,880. And 2 factorial times 2 factorial times 2 factorial is equals to 8. So 362,880 divided by 8 is equals to 453, or 45,360. And for the fourth problem in permutations, and second with permutation with repetition, just like the problem in number 3, its condition is the vowels always come together. So in the word committee, there are nine characters, or 9 letters, COMMITTEE, and its condition is the vowels always come together. So the vowels are O, I, E, and E. Now, if the vowels always come together, we count it as one. So the characters only have 1, 2, 3, 4, 5, 6. So 6 factorial over the same characters, the M, so over 2 factorial. Multiplied it to the arrangement between all the vowels that comes together. So O, I, E, and E are 4 over the same characters, letter E, 2 factorial. It is equals to the 6 factorial over 2 factorial equals to 180, multiplied to 4 factorial divided by 2 factorial is equals to 12. So 180 multiplied by 12 is equals to 2,160 possible outcomes if the vowels always come together when the word committee is arranged. Now for the last problem in statistics and probability, the combinations. So the problem is, a box contains 12 blue balls, 10 yellow, and 8 red balls. In how many ways can you select 7 balls if there are no restrictions? Now, the sum of all the balls are 30. So 12 plus 10 plus 8 is 30 because no restriction. So we choose combination of 30 and taken 7 balls. So 7 balls, 30 taken 7. So combination of 30 taken 7 is equals to 30 factorial divided by 30 minus 7 quantity factorial multiplied by 7 factorial. The answer for combination of 30 taken 7 is equals to 2,035,800 possible ways in selecting 7 balls from a box containing 12 balls, 10 yellows, and 8 red balls. The second condition in this problem is they are all blue balls. So, selecting from a box containing 12 blue balls, so selecting 7 balls is we take the combination of 12 because there are only 12 blue balls and it says that all balls must be blue, and combination of 12, and we take the selected 7 balls, combination of 12 taken 7, it is equals to 792. For the third condition, it says that there must be 3 blue balls, 2 yellow, and 2 reds. So we take the 12 combination of 12 blue balls and selected 3 from the 12 and multiply it to the yellow, 10 yellow, combination of 10 and taken 2, and lastly for the red, 8 reds, combination of 8 taken 2. It is equals to combination of 12 taken 3 is equals to 220 multiplied by the combination of 10 taken 2 is equals to 45 multiplied to combination of 8 taken 2 is equals to 28. So 220 times 45 times 28 is equals to 277,200 possible ways in selecting 3 blue balls, 2 yellow, and 2 red. For the fourth condition, so it says that exactly 4 balls are yellow. So in combination, 4 balls, 4 yellow are taken, and 3 combination of red and blue. So we take the combination of 10 because there are 10 yellows, and takes 4, multiply it to 3 combination of 12 because the blue balls and red balls are mixed in the 3. So 12 plus 8 is equals to 20 taken 3. So combination of 10 taken 4 is equals to 210 multiply to combination of 20 taken 3. So times 1140. 210 times 1140 is equals to 239,400. So 239,400 are the possible outcomes if exactly 4 balls are yellow. For the last condition, it says none is blue. So in a box containing 12 blue balls, 10 yellows, and 8 red balls, you couldn't pick up the blue balls. So 10 yellows and 8 red balls are the only allowed. So 10 plus 8 is equals to 18. So it is combination of 18 taken 7. So it's equals to 18 factorial over 18 minus 7 quantity factorial multiplied by 7 factorial equals to 31,824 possible outcomes if none is blue. For the last condition in this problem, the condition at least 4 are blue. So there are 4 possible outcomes or answers in this condition. So it is possibly 4 blue balls, 4 blue combined with 3 combination of yellow or red, or 5 blue combined with 2 yellow or red, or 6 blue combined with 1 yellow or red, and last is all 7 blue. Now, for the 4 blue and 3 yellow or red, it is combination of 12 because there are 12 blue and taken 4 multiplied to combination of the combined yellow or red 10 and 8 18 combination of 18 taken 3 equals to 403,920 and 5 blue and 2 yellow or red. So combination of 12 blue taken 5 balls multiplied to combination of 18 taken 2 equals to 121,176. And for the 6 blue, combination of 12 taken 6 multiplied to combination of 18 taken 1 equals to 16,632. And for the all 7 blue, it is combination of 12 taken 7 equals to 792. So if 4 blue and 3 mixed yellow and red, so there are 403 and 920 outcomes. If 5 blue and 2 yellow or red, it is 121,176 possible outcomes. If 6 blue and 1 yellow or red, there are 16,632. And if all are 7 blue, there are 792 possible outcomes.